I want to give those of you a chance to understand the formula Q equals mc delta T that we're maybe struggling in class. In chemistry, we're going to use a wide variety of formulas that sometimes you'll hear me call plug and chug. They're basic algebra. So let's talk about how to solve an algebra problem first. The basic algebra problem that I'd like to start with is 6 equals 2x. Now, most people will look at that and they can pretty easily solve it. You know, you look at it and you're like, well, I know the answer is 3. But if you were to solve it algebraically, you'd have to divide this side by 2 and divide this side by 2. The 2 would cancel over here. You would get 6 divided by 2 equals 3. So that would be x equals 3. When we start using letters in chemistry, it doesn't get much more complicated than that. For example, if you have x equals yt, and someone says, well, you've got to solve for t, you can do the same thing. Divide this side by y, divide this side by y, and you'll get t equals x over y. So in our problem that we're looking at, we have Q, which stands for heat, equals M for mass, C for specific heat, and delta T, which means change in temperature. Sometimes these problems are really straightforward. You just have to say, well, how much heat was absorbed or released? And then in that case, you just do the mass times the specific heat times the change in temperature. But sometimes you'll have to solve for specific heat. In the problem, they'll give you the heat, they'll give you the mass, and they'll give you the temperature, but you have to find out what the specific heat of the metal is. In that case, we're going to divide by M and delta T. Cancel out the M, cancel out the delta T, divide by M, divide by delta T. I like to rewrite this as C equals Q over M delta T. Now I can just put the numbers into my calculator. Now we'll get a little bit trickier throughout the year. For example, D equals M over V. If you need to solve for V, you need to go through a couple other steps. You have to multiply both sides by V. This cancels out. You get VD equals M. Divide by D, divide by D. This cancels. V equals M over D. Now you might be looking at that and thinking, well, I don't really need to understand that yet. And you're right. Let's stick to Q equals MC delta T. So in this first example, you can see here that I had a certain amount of energy, and that certain amount of energy came from 55 grams of aluminum, which has a specific heat, which is C of 0.9, and it changed the temperature from 22 to 94. Always remember that delta T equals the temperature of the final temperature minus the temperature of the initial temperature. And so usually on my keys, you'll see that I have final minus initial to give me that delta T number. Now in my calculator, I just typed in M, 55 grams, times C, 0.9, times delta T, 72.2, and this is the answer that I got. Don't worry about rounding right now, as it's not something we're really thinking about. For the next problem, it's talking about how much heat is added to ethanol that makes its temperature rise from 18.2 to 32.8. And it's going to give me the specific heat of ethanol. I never have to know that. But in this case, it wants to know what is the mass of the ethanol sample. So as you can see there by my highlighting, the first thing I like to do is I like to figure out what's given to me in the problem. So I'll say, well, they gave me the Q, 655 grams. I also know that the temperature went from 18.2 to 32.8. So the change in temperature was 14.6 degrees Fahrenheit. Finally, in the problem, they gave me the specific heat of ethanol. So I write those out. From there, I can start rearranging my original problem. So Q equals MC delta T is what I'm given, but remember, I'm going to divide by C delta T on this side, divide by C delta T on that side. This will make sure that I get M by itself, because M, after all, what is the mass is what I'm looking for. So rewriting the equation, M equals Q over C delta T, I get an answer of 18.7 grams. The next one, luckily again, is looking for heat. So heat is Q, and I have no need to rearrange my problem there. It says, how much heat does 500 grams of aluminum absorb when its temperature goes from 12.5 to 7.6? And again, gives me the specific heat of aluminum. So I start out by writing all my givens, my mass, my change in temperature, and my specific heat. And then I call this just plug and chug. So Q equals MC delta T, which is going to equal 28,935. Now let's talk about a calculator for a minute. In my calculator, for problems like this, the way that I type it in is that I'm going to go to my Q value, Q divided by C divided by delta T. Did you catch that? I did 655 divided by 2.4 divided by delta T, which is 14.6. Now you'll notice there that I put the divide by symbol, not the multiply symbol. That's because I don't like to use parentheses, because it's just an extra button I have to push. So every time something's on the bottom of the equation, I use divide by, divide by. When it spits out my answer, we can just, like I said, round it for now to whatever. We will talk about rounding a little bit later in chemistry. Right here, when I'm doing this one in my calculator, this is simple multiplication. The mass is 500 grams times the specific heat is 0.9 times 64.3, which is going to give me this number you see here, 28,935. I suggest you stop it at this point and try the next one if you haven't done so already. The next one involves scientific notation. Scientific notation, if you don't remember it, it's pretty easy, but I want to show you how it works. In scientific notation, you are given numbers that look like this. 2.74 times 10 to the sixth. That would be something written in scientific notation. To solve for that, you're just going to move the decimal point over 6 places. So I'll show you 2.74, and we're going to go ahead and move our decimal point over 1, 2, 3, 4, 5, 6. And then that's where the new decimal point will end up. Now, obviously, I have to fill in zeros here. So that's going to be my final number. It's going to be 274,000. And as you can see there, that's a lot of zeros to write, and this is how it works in chemistry. Sometimes the numbers get really big. If you want to know how to put that number into a calculator, it's really easy. You type in 2.7, and then we use this button EE. It's down at the bottom. EE 6. That's 2.7. I'm sorry, I forgot the 4, but 2.7 EE times 10 to the 6th. And as you can see there, again, sorry, I forgot the 4, but it's the same number that I'm seeing over here. Sometimes the numbers will get too big for our calculators and we need to utilize this technique. But for these ones, they're pretty easy to just transfer in my calculator alone. So when I do Q equals MC delta T in this case, the first thing I do is I start out again with my givens. 2.5 times 10 to the third joules. That's joules of heat. Q gives me the substance in grams. And then the temperature is 60 degrees Celsius. I need to rearrange my equation. Q equals MC delta T. So I need to get C again by itself. Now you can feel free to use these again if you've already gotten C by itself before. You don't have to show your work every single time. And then I put it in my calculator and I get this. So I'd like to put it in my calculator for you so you can see where I got that. I can either use this button, E to the third, or I can just go ahead and convert it in my head right now. 2, 5, 0, 0. Oh, sorry. 2, 5, 0, 0. That's my Q, divided by my M, 1, 1, 2, 3, 4 zeros. And then again, gonna hit that divide by button again, really important, 60. So I get my answer that looks like this. Again, if you'd like to flip this back into scientific notation, it goes the other way. 1, 2, 3 places in the other direction. So you actually get 4.17 times 10 to the negative third. That's how you work scientific notation in the other direction. Now, let's move along. This is one of the ones that I gave you the example in class. The most important part of this is that you are taking these and you are going in order. Define as many variables as you can. How much heat did the water gain? How much heat did it lose? And what is the specific heat? If you're not going in order the very first time, then you're going to get yourself pretty confused. So I'll give you a hint. When I'm defining variables, I don't have Q. Q doesn't exist yet. I know things like 5.2 grams of the substance. I know that there's 505 grams of water. I know that the specific heat of water is always 4.18 joules per gram. This one is always going to be this. And I'll write that on the board for you so you don't forget. Okay, then comes the temperature. Now the temperature, I was very careful to kind of color code. The substance, whatever this is, I called it the metal because a lot of times it is. The substance is heated to 42.5 and then it drops down to 35.7. The water starts at 25 and then raises to 35.7. In these calorimetry examples, the final temperature will always be the same for the water and the metal. So notice this right here. This number and this number will always be the same. T final minus T initial is going to give me the change in temperature. Now, as I work my way through this, it says, how much heat did the water gain, right? So I go ahead, I do my Q equals MC delta T with everything involving water. This times this times this. I get this answer. This answer is how much heat the water gained. We know that the heat gained by the water is the heat lost by the substance. So I'm going to take that number right here and I'm going to plug it in for the metal. So in other words, you find that first, and then you know this is the heat lost by the metal. I want to point out to you the negative sign. Heat lost is a negative sign, but then the temperature is technically a negative sign as well because you're going from a higher initial temperature to a lower final temperature. Here's a hint. If you just ignore the negative signs altogether, you won't really even get yourself messed up because you can't have a negative mass and you can't have a negative C. So feel free to keep the negative signs in or just forget about them altogether. Once you have this number, you can go ahead and start solving this equation. What is the specific heat? I rearrange my equation just like I did above, and I get Q C equals Q over M delta T. I plug that into my calculator, all in yellow here for metal, and I get an answer of 627 joules per grams times degrees Celsius. Now, as we look at this one, it's a little bit different. It says a cup of 179 grams of water, which remember is the same as 179 milliliters of water, at 17.0 degrees Celsius has a chunk of silver added to it. The temperature of the water rises and the temperature of the silver is going to fall from 104. But instead of the specific heat of the silver, they give us that. We're going to determine the mass of the silver this time. So we know the mass of the water is going to be 179 grams. We know always the specific heat of water is 4.18 joules per gram times degrees Celsius. And we know that the water went from 17 to 28.3. Now the metal goes from 104 to 28.3. Always remember they come to the same final temperature. These two numbers should always be the same. So the water has a change in temperature of 11.3, while the metal has a change in temperature of 75.7, or negative if you're counting the negative numbers. The C of the metal is given to us in the problem. It's right here. It's 0.24 joules per gram times degrees Celsius. And so that's pretty much all we know here from the problem. So the very first question is, how much heat does the water gain? So very, very simple, Q equals MC delta T. And I made it blue so it matched up. We're going to put it into our calculator, Q equals MC delta T, and we get that. Now this number right here, I'm going to go ahead and plug back in here. So the Q of the water, or the heat that the water gained, was 8,455 joules. So how much heat does the silver lose? Q lost equals Q gained. So this is what was gained. So that is exactly what was lost. Now we're on to the final part. We have the Q of the metal, the C of the metal, and the delta T of the metal. So all we're looking for is the M of the metal. So I'm going to divide by C and delta T on this side, divide by C and delta T on this side. These are going to cancel out. It's going to give me M equals Q over C delta T. I'm going to plug that into my calculator. Don't forget again, divide by, and I get 465 grams. This is how every single one of these is going to work. Every time you encounter one of these problems, it's going to be exactly the same. So you have some object, usually it's metal. A lot of times it's in boiling water, not necessarily though. And that metal object has some known initial temperature. And you also, in the case of our lab, know the mass. You're then going to put that metal object into the coffee cup calorimeter, which is that insulated styrofoam cup full of a known amount of water. We're going to know exactly how much water that is, and this is going to transfer over into here. As the heat is lost by the metal, the heat will be gained by the water. You'll have all the variables you need, the amount of grams of water, the specific heat of water, and you'll be able to find out from there how much heat the water gained, because you'll know the temperature change after you put it in there. So the last thing that I want to do is I want to make sure that when you look at my answer key, you're not super crazy overwhelmed. I tried to color code things to make things easier for you. These are long problems, but they are certainly not impossible. All right, the most important thing is that you separate the metal from the water. So this is a 65-gram piece of metal. And the 65-gram piece of metal goes from 100 to 25, right? So that's my delta T. Now, it's placed in 70 grams of water, and that 70 grams of water goes from 15 to 25. So it has a delta T of 10. So don't forget that that 25 is the final temperature of the metal and the water. So this one asks, what's the specific heat of the metal, much like the lab. So the first thing that you want to do is you want to work yourself through Q equals MC delta T of the water, because we know that the heat gained by the water is the heat lost by the metal. So we find the heat gained by the water to be 2926. Plug it in here. Negative 2926. Don't forget negative signs. You don't really need them. You can kind of ignore them, because if you ignore the negative sign all the time, then it will come out right. We're going to say Q equals MC delta T, but we're going to solve for C. Divide by T, divide by M, divided by T, divided by M, which gives me the C formula. I plug these numbers now into my calculator, and I get the C value, which is over here. So just make sure you're following my color code and you're doing the water with the water and the metal with the metal. This number, 4.18, always going to be there for water. That's the specific heat of water, and a lot of times they don't give it to you in the problem. This one is a little bit weird. It's about a glass cup, but again, it's the same thing. We're going to find the water, how the water's changed, and how it changes the glass cup. And it tells me the specific heat of glass of the cup, so I'm going to find the mass of the cup. So there you go. That's calorimetry, and that's how those problems are done.